We can title this the real numbers or the number families. We're going to be taking some other notes, so take out some. We're not going to write anything else in it. It's just a diagram to show that, and if we color code it, here's the natural numbers. Those are all our counting numbers. Those are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. All of those numbers are inside the circle with the whole numbers, because whole numbers just add a 0. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah.
Messed up diagram.
You can start drawing it again then.
Oh, I'm sorry, drawing circles.
And then this circle here, the integers include the negative whole numbers, but they also include the whole numbers, and they also include the natural numbers. So that's why the red and the green circle are inside of the blue circle. Anything that can be written as a fraction is this purple circle here. And any whole number can be written as a fraction, because 5 is the same as 5 over 1. And any negative number can be written as a fraction, because negative 3 is negative 3 over 1. So that's why the blue, the red, and the green circles are inside the purple circle. And the purple circle includes... The purple circle includes all of your decimals and any other fraction. There are some numbers that cannot be written as fractions, decimals that don't end without a pattern, and that is a separate circle right here. Those are your irrational numbers. But putting them all together, those are all the real numbers that we have. So in this one, all I want you to figure out is which numbers are rational and which ones are irrational. And again, we're going to use the Q for rational numbers and the Q with the bar over top of it for irrational numbers. So for rational numbers, we're looking for fractions, decimals that end, or decimals that repeat. So one of the things you're going to need to do for tests and quizzes is remember these definitions. What is a rational number? A rational number is any number that can be written as a fraction, any number that can be written as a decimal that ends, or any number that can be written as a decimal that repeats. So 3/4, is that a fraction? Yes. So we could put this one is a rational number. Is a rational, not irrational. It is a rational number. Okay? The square root of 2. Now, irrational numbers include special numbers like pi. They include decimals that go on forever without repeating. And they include some square roots. And the square roots that I include are ones that you can't simplify. For example, the square root of 9 is equal to 3, so that wouldn't be an irrational number. But the square root of 2 is not one that you can solve. It's not 1.5, because 1.5 times 1.5 is 2.25. So this one is an irrational number. In fact, if you go to your calculator, if you take out a calculator, and you type in the square root of 2 into your calculator, it's going to give you a bunch of decimals. And it's going to stop because your calculator only has so much room. But can you see that nothing's repeating so far?
Yeah.
Okay? If you would go to a computer program, if you wanted to see, are there even more decimal places? And you wanted to find the square root of 2. Oh, I spelled sport of 2. There is no such thing. Square root of 2. On this program, it'll tell you more decimal places. In fact, it tells you 1.4142135623730950488880. Whew. And if you want to, you can click on the button and see even more digits. And if you want to, you can see even more digits and more digits and more digits and more digits and more digits.
It doesn't look like it's repeating at all.
And as you can see by the dot, dot, dot here at the end, it just keeps on going.
Would that be like million, trillion, quadrillion?
That is a lot of digits. Okay, so now we go back. Here we go.
Mr. JR,
So that makes it an irrational number.
could you go back to that page, please?
You want to go back to that page temporarily?
Go all the way, it's like slide up.
Slide up. Okay.
This is tens, hundreds, thousands, millions,
Yeah.
billion, 10 millions, 100 millions, and billions. Then what would this be?
A big number.
I have that much money.
Okay, next one. 5.456. Is this a decimal that continues on forever, or is it one that stops? So then is it rational or irrational? It is rational. What about pi? Pi is irrational. What about 4/9? 4/9 is a fraction, so that is rational. And square root of 4. Well, square root of 4 is equal to, it's equal to 2. And because it's equal to 2, it is rational. This one, we look, it doesn't repeat itself. This one will be irrational because it keeps on going. The dot, dot, dot at the end means that it keeps on going. This one, do you see that there's a pattern that's repeating itself? It's 1, 3, 1, 3, 1, 3, 1, 3. So it is rational. Now, one thing that I find helpful, okay, one thing that I find helpful is when I'm asked to decide all the families that a number belongs to, I put my numbers into two categories. There's your rational numbers and your irrational numbers. And I always list them from the smallest family to the biggest. So the smallest family is your natural numbers, 1, 2, 3, 4, 5. Then your whole numbers include 0. So this is 0, 1, 2, 3, 4, 5. Your integers, and remember you could also use that symbol. Your integers include your negative counting numbers and your positive ones, so like -1, -2, -3, and so on, and then 0, and then 1, 2, 3. Then your rationals add in the fractions, and then finally your real numbers are all numbers. So I split them into two categories, and I start smallest to biggest, smallest to biggest. Then when you go to look at a number, like our first one is 44. What is the smallest family that 44 belongs to? First of all, is it part of the rational group or irrational? It's part of the rational. Now, of the rational ones, what's the smallest one it belongs to? The natural ones. So because it's natural, you'd also include all the ones underneath it. So that one is 5 of them. There's 5 families that 44 belongs to. Right? And that's easy to remember because this spells the word Newarker. Newarker. Okay, second one, -3. Is that a rational number or irrational? It's rational. No, it's rational because you can write it as a fraction. It's -3 over 1. Now, what is the smallest one in the rational families that it belongs to? The smallest one is an integer. So you pick integer, but then it's also a rational number and also a real number.
Oh, R means real?
R means real. Okay. 0. Is 0 a rational number or irrational?
Rational.
It's rational. What's the smallest one it belongs to?
10 kilometers. That's getting that.
Whole. Because natural numbers start with 1, 2, 3, 4. Whole numbers are 0. And whichever one is the smallest, you include all the ones underneath it.
Oh, I kind of get it now.
Okay? So that's why I find writing it out this way as 2 columns, 1 rational, 1 irrational. Whatever you find is the smallest one it belongs to, then it will include everything underneath that. 5/9. Rational number or irrational? 5 over 9, yep. It is rational because it's a fraction. Is it a natural number? No. Is it a whole number? No. Is it an integer? No. So the first one you can do is rational number, and of course it's also going to be a real number. The next one, rational or irrational. It goes on forever, so it's not a decimal that ends, and it's not repeating, so it's irrational. Oh, this one, we got a problem here. There we go. There we go. And finally, negative 2.3. Is it a rational number or irrational? It's rational because it's a decimal that ends. Is it a natural number? No. Whole number? No. Integer? No. So then it's just this one and this one.